Hello, and welcome to my video. This video is about parametric equations and how to find the derivative and the second derivative of both. Now, this is the formulas we will be using. X equals cosine to the 7th power of t, and y equals 8 sine squared of t. So, the first thing we want to do is take the derivative of both of these equations. We're going to start with x. So dx over dt equals, you put the 7 out in front because this is the power rule. Let's do the power rule. Cosine to the 6th t, simple. And then times the derivative of cosine, which is negative sine of t. You can move this negative in front of this equation if that makes you feel better. But I'm going to just leave it where it is because moving it now would be useless. We just have to move it again. Now, dy over dt equals, you take the squared and you multiply by 8, that gives you 16. Then you multiply that by cosine of t, and you have the derivative of dy over dt. Now you take these two equations and you put them together in a fraction. Dy on top, dx on bottom. That's why we have dy over dx for the derivative. So you put 16 sine of t times cosine of t all over. Now we can make this whole fraction negative because of the denominator having that sine squared, or sine t, negative sine t. 7 cosine to the 6th power of t times sine of t. And there you have the first derivative of the function. Now that you had a minute to absorb this, if you paused the video just now, well, I put the derivative here. Now we're going to have to find the second derivative, and that's going to be about 3 times as hard as finding the first one, just like all second derivatives. Well, not all of them, but a great many are. What I'm trying to say is this is going to suck. So the first way we take the derivative of the derivative is going to be to cancel out from the top and the bottom. Get rid of these two signs, the sine and cosine at the top, basically, and the sine at the bottom. So we can just whoop, and the 6 goes bye-bye, gets turned into a 5. So now we got, if we do this, 16 over 7 cosine to the 5th of t, which is still ugly. Now, the way we can kind of pretty it up a little bit is to factor out the 16 and the 7, because we don't really want to do anything with those. They remain negative, as does what we did over here. So they're negative, but we can take the derivative of what's left, which is cosine 1 over cosine to the 5th t. We take the derivative of that, and we're almost home. Now, we got to use the chain rule on that because, well, that's them the rules. So, first thing we do is we see that, well, we see that we can take this function and make it into cosine to the negative 5 power of t. Then we could just take the power rule. Not really much else to do. So negative 5 comes out in front, and cosine to the negative 6, because we're subtracting by 1, that 5 gets bigger. It goes to negative 6, which sucks. But then, all we gotta do is take the derivative of cosine to the t. Okay. And that just equals negative sine of t. Multiply that by the negative 5 cosine t. We don't really have to do anything else. We can just put negative 5 up on top, because come on, the negative 5 goes on top of the fraction, because we're making this into a fraction. To get this over with, it goes cosine of 6 to the t times negative sine of t. Okay. And this is still negative right there. Sucks, but because I hate negatives. But good thing is this sign is a negative. So all we gotta do is put a 1 over it, multiply, which equals positive 5 sine of t on top of in the numerator, okay, over cosine. I am terrible today. Of 6 to the t. There you go. And that's it. Now we can go back to multiplying this by a negative and getting, since we can multiply this 5 by 16, we get, this is a negative, by the way, again, or yeah, this is a negative, by the way, again. So we got 80 sine of t all over 7 cosine 6t negative. Which is ugly, yeah, but as we can do. Now, in order to get the second derivative, this is not the only thing we have to do, unfortunately, because of parametric equations, nothing's ever easy, like it was in Calc 1. So what we got to do is we got to take the derivative of x, of this x right here, cosine to the 7th, which if you don't remember, was, in fact, negative sine, or let's just put 7, let's put 7 cosine 6 t times sine of t, which is awesome. So awesome. Let's stick the negative right there. So awesome, because this sign cancels out this sign, which is cool, which leaves us with these two. Now, in order to get rid of this at the bottom, because we have to get rid of it, We can't have a freaking denominator of a denominator. That's just ludicrous. We have to get rid of it. So, this is going to suck, but we multiply the sevens. And that gives us 49. Now, we do not multiply the cosines because they're just cosines. So, they're the same. But what we do is we add the powers. It's a rule. Have to add the powers. Power divided by power. You add them together, there you go. So you get 12 of t. And all this is over 80. Pretty cool. Now, this is where you end. This is the second derivative. 80 over 49 cosine to the power of 12 to t, which is a mouthful, but is also our second derivative. Easy peasy lemon squeezy, which is a dorky thing to say, but still. It was a little shoddy here in the beginning, but that's just the way it is. And it's pretty simple actually. Just take some algebra and also take some calculus knowledge, calc 1 knowledge, and you can get these two functions easily. I mean, they take a lot longer. I mean, this video is taking 12 minutes, so it's pretty long. But yeah, you don't need the second derivative for the Cartesian equations, though. You can just use the second derivative to find those. Find the m and the b. You just need the first derivative. You don't need the second. Now, be careful with these sines and cosines because they are real deceivers. They can sneak up on you. You may think it's gone, but then it comes back. They're like cockroaches. Sine comes back, cosine comes back. When you're taking the derivative, these things tend to bounce back. So be careful with these types of equations. And that's the end of my first video. Tell me what you think. Tell me if my math is right, or if it's wrong, or if you have a better way of doing it. This is the only way I know how to explain it. This is simple to me. This is easy to understand for me, and I'm hoping it's easy to understand for you. This is for Calc 2, parametric equations, finding the derivative and second derivative of these two functions. Thank you, and goodbye.